Hi there, it's Mr. Clark. Welcome to lesson 12.1.1 on the pitch wheel. So at this point, this is unit 12. It may become unit Neo-Riemannian theory at some point in the future. I haven't quite decided how it's going to fit in, because this is related to what we've been doing, but also kind of, if we've been going on a single track, it kind of takes that track and veers off in a bit of a different direction. So up until now, we've been considering purely tonal harmony, where every example is centered in a key or moves between different keys with, tonicization modulation. And most of the time we've been analyzing with Roman numerals. But as we get into all these chromatic chords, it starts to happen a little bit less. And we've certainly gotten away from your standard just diatonic 1, 2, 3, 4, 5, 6, 7, 1 chords. So in this chapter, we're going to consider chords as their own entities that just exist in space outside of keys, and see how individual chords relate to one another and how that can create some interesting chord progressions. So we introduced the law of laziness all the way back in some of the early ear tunes, and this law of laziness is the basis for all of Neo-Riemannian theory. So, just some preliminary things to help us get into this space. We have a couple different visualizations that we're going to use, and the first one is the pitch wheel. So, at first glance, this is not terribly exciting. We've put all 12 pitches around a circle. Yay. I haven't listed any enharmonics. I could put like A sharp slash B flat, B slash C flat, but there's no reason to do that. For the purposes of this unit, enharmonics will be considered to be exactly equivalent. So not that exciting first glance, but it allows us to easily visualize certain properties and connections that are otherwise somewhat abstract and hard to think about. So, for instance, we've talked about how the augmented triad evenly divides the octave. It's all major thirds. Well, it's obvious when we draw it on the pitch wheel. C, E, G sharp is an augmented triad, and we can see that the distance between each of the three notes is exactly the same. We've also talked about how there are only three distinct diminished seventh chords, and that's easy to see when you draw them on the pitch wheel. All of them are separated by minor thirds. So we have one starting on C here, one starting on C sharp, one starting on D. But if we try to draw one starting on D sharp, well, oh wait, we just get exactly the same as the one starting on C. So that makes it a little more obvious. Similarly, any triad you have will form some sort of triangle, because there are three different pitches and 3 points, as long as they're not in a straight line, to find a triangle. And any seventh chord will be some kind of quadrilateral. Equilateral triangles and squares are very symmetrical. Technical term, not actually a technical term, but like, through every angle and through every perpendicular bisector, they're symmetric. Other triads and seventh chords only exhibit partial symmetry, which can lead to some interesting results. So we have a C major triad here. And actually, look in here, this is originally in color, but it's not on my printout, so here we go. So if we reflect the triad across each perpendicular bisector, we can get new triads. So the perpendicular bisectors, in case you don't recall your geometry class, are the lines that bisect a line segment, go exactly through the midpoint, and are perpendicular. It meets it at 90 degrees. So those are very light sort of dotted lines in these diagrams. And we start with our C major triad in black. If we reflect it across the first perpendicular bisector, we get this red triangle, which is C, D sharp, and G. Oh wait, it's C, E flat, and G, which gives you a C minor triad. If we reflect it across the second perpendicular bisector in the middle here, then we get C, E, and A. So we go from C major to A minor. And then this last one We go from C major to E minor. So all three of those triads are closely related to C major since they share two chord tones, but this isn't this property of being closely related isn't reflected in their Roman numerals, because respectively we have 3, our E minor triad is 3. That's not common. 6 is pretty common. Minor 1, not super common in major keys. And it's also not their frequency of appearance. So these are the sorts of chord relationships that we'll be exploring in this chapter. They're closely related, not because of Roman numeral properties or key properties, but because of the properties of the triads themselves. So, see you next time for another visualization.